Hello. So, in last class we have discussed regarding the basics of network analysis systems. Okay. In that we have discussed what is exactly the network analysis process, then what are all the techniques are there within the development of a network we have discussed, that is AOA systems and AON system, that is activities on nodes and activities on arrows. Okay. So, AOA stands for activities on arrows. So, here we are going to concentrate more on arrows connections, that we are going to discuss in detail in our previous classes. Okay. Then the next part is activities on nodes. Here the nodes are going to play a major role while connecting activities or different tasks, I can say. Okay. So, before going to solve the techniques, that is the logical related issues related to the network diagrams or network analysis, first we need to understand what all the basic elements are there within the network analysis. Right. So, what all the elementary parameters we need to discuss, because while constructing networks we are going to come across some basic definitions or the basic terminologies, I can say. So, now we are going to discuss one by one what all the basic terminologies are get involved in this activity diagram. Okay. So, in elements of network construction, the first one says something about event, right. So, what is an event? So, in general we will use this terminology. Yes, the event is going on. Yes, the event was nice. So, we have organized an event called so and so, something like that. Usually, we are going to use this terminology in our day-to-day activities. Yes or no? So, here in network analysis, event is nothing but the start or end of an activity. Yes, if for example, this is after one hours we have to give one program, something like that. So, that starting point of that program or the task is nothing but your event. What are all the procedure or precautionary measures we are going to take to start that particular activity or task, that is the starting or end of a activity is called event, and that event we are going to usually denoted by a circles, and these events they are not going to consume any money, that is time and resources. So, events are not going to consume any time, money, resources. Right. So, event is denoted by circle and it represents the nature of the project, I can say, and it is always starting or end of an activity is called event. Then coming to the second point, activity, because in event we already discussed activities. Okay. Then what is the specific of activity now? Activity, usually we are going to use this terminology in our day-to-day activities. See, activities is nothing but this is a task which is nothing but a process. Yes or no? So, every task we are going to represent it as an activity. Yes, it's one process. That process in turn involves resource, time as well as money. So, that is the main difference between activity and an event. Okay. So, event it does not consume any resources, neither materials nor time, whereas an activity it consumes all these three parameters. It requires some resources because we need to finish the task. No, that is why. For example, here the person will going to start from the journey to 1 to 2. Let us say an example. Okay. So, here the person will start at this point and he will move towards the second point. So, this A we can represent it as an activity, right. So, this is the start of an activity and this is the end of an activity. The start and end of an activity is nothing but your event. Yes, in between the connection between the starting point and ending point of those two events we can call it as activity. That is it, because it consumes. See, to travel from this point to this point we require some time, it must consume some time. To finish some task from here to here it requires some resources, it requires some money. Entire flow will take place to reach that start to end. That entire phenomenon we can treat it as activity, and within that activity, for example, within these events as well as an activity we come across the concept called predecessor and successor events. First we will discuss something about related to event. Okay. So, in event we have two kinds of events, one is the successor event and one more is the predecessor event. Now, the successor event is the one which follows another event. Successor event is the one which follows another event, right. Whereas, the predecessor event is the one which occurs before another event. is called predecessor event. Because while constructing some network diagrams, we come across, because while solving some logical related problems, so the problems may be of descriptive type. So A is a predecessor of B, or B is predecessor of some other tasks, I can say, like something like this. They are going to link the nature of the projects, I can say. So by observing those nature of the project, by observing the predecessor as well as successor activities as well as events, we need to construct the diagrams, how they are interdependent with each other, how the entire duration of the projects will going to take place, how the total project of that, total project time will going to be varied from activity to activity, something like that. We are going to work out as a network analysis problems, I can say. That we are going to discuss in our upcoming classes. Okay. So in events, we have two kinds. One is a successor event and a predecessor event. They are nothing but the event that follows another event is called successor event. The event that occurs before another event is called predecessor event. Similarly, in activities, we have predecessor activity as well as successor activities. The concept remains the same. Activity that required to be performed before another activity is called predecessor activity, whereas successor activities is the activity that can be performed after the performance of other activity is called successor activities. And before going to start with the next, how the total project times and the durations will going to vary, we need to come across one more important phenomenon called dummy activity. What is this dummy activity? Just now I have discussed something called activity. Yes, activity is, it consumes some time, resources, money, and it is the line joining between two events, I can say. Yes, start to end, that entire process, task, we can call it as activity. Yes, but what about dummy activities? While constructing network diagrams, right, it might be of any kinds, I can say, CPM related or PERT related, I can say. While constructing that network analysis or network diagrams, some connections are required. Yes, to meet those activities, some connections are required, right? They are nothing but your predecessor and successor activities, of course, but the one which does not consume any time, yes, which does not consume any time or resources, but they are the role or they are the important parameters to link the activities of different places, I can say. For example, here we have one activity something like this, and at the same time I am going to represent one more dotted line something like this, right. So after completion of these two, of course the next activity will going to run something like this. Okay. Then what it indicates? This dotted line indicates dummy activities. Yes, the name itself says dummy activity. Dummy activity means that activity which is required to give the interdependency of an activity, but it does not consume any time, resources, nor the money. So they are going to start simultaneously, I can say. Okay. So once I am going to assign something called 1, 2, 3, 4, so on. Yes, after completion of 1, 2 will start. That indicates this 3 is also begin with the same concept. That indicates, because they are the dummy activities. We need to introduce forcibly, or depends upon the nature of project or nature of the network analysis, we are forced to introduce dummy activities. So they are not going to consume any resources here. So those activities are treated as dummy activities, and they are going to say the dependency of other activities. Okay. Once we are going to solve some problems, we will come to know the reality of these terminologies. Okay. Then the next point says something about the total project time. The name itself says total project time. Of course, time is nothing but it's a time required to finish the task, I can say. Okay. Then what about the total project time? Of course, this is the total time required to finish. Yes, it's the total time required to finish the entire process, starting to end. That whole time required to finish the task, we can call it as total project time, or total time required to finish the task or to finish the project, right. That is your total project time. Then coming to the duration, next definition. So the next definition says something about duration, right. The name itself says duration. Duration means what? This is the time required to finish that particular task. Yes or no? If whole project we are going to come across, yes, that is total project time. It's nothing but the combination of the durations required to finish one task to other tasks, I can say. So, for example, to reach one place to another place, we have around 6 stages. Let us say an example. Okay, we need to overcome 6 stages to finish that particular task. So, starting point 1 to reach 2, that in between gap is called the duration of that first task, duration of first activity I can say, activity A I can assign. Okay. So, A required 2 days to finish the task, that is nothing but your duration of the project or duration of that particular activity. See here, we should concentrate more on the project total project time and duration. Of course, by observations they are looking like one another same probably, but actually speaking they are not remains the same. So, duration is the one which is mentioned in terms of time required to finish the task or finish that particular activity, that is duration, and we are going to denote it by using capital D. Whereas, the total project time is the combination of all the durations come across within the activities I can say, activity 1, 2, 3, 4 so on n number of activities which requires D1, D2, D3 so on dn number of durations. Combining all those parameters we will come across what should be the probable or tentative or estimated projected time to finish the task. For example, we can easily observe these things in practice I can say. For example, we have planned to construct a residential building, let us say an example. Okay. So, before going to start with the project, being a design engineer or project manager or a site engineer, he will decide what should be the starting point or starting day of the project and what should be the last day of the project I can say, that is the completion day of the project I can say. Within that I can decide what should be the duration the project can consume. Yes or no, that we can easily call it as a duration because that is one task. If within that task if we have n number of activities, yes, that is first one earthwork excavation in foundation which requires 1 week to finish. That is one task, that is one activity I can say. Then the second task is after earthwork excavation, we need to do some anti-termite proofings. That is second task which requires 2 days, let us say an example. Similarly, so on, finishing, then flooring, painting, plastering, interiors, exteriors, etc. These are the individual entities which are get involved within the buildings I can say. So, these are in turn require their own durations to finish the task. So, the combination of all these tasks will in turn give you the total project time. Right, then duration between 2 tasks or one activity, what is the time which will consume, that is duration. So, now we are going to come across the main basic 4 time requirements of the network analysis, that is earliest start time, earliest finish time, latest start time and latest finish time. These 4 time parameters will going to play a major role in network analysis systems, because by observations they are looking like what is the major difference between all these things, earliest, latest, yes or no, start time, finish time, how they are going to interlink, that point we are going to discuss now. Okay. So, we will discuss one by one. So, the first one says something about earliest start time. So, the name itself says earliest start time. So, this is the earliest time in which an activity can be started. So, earliest start time is the time in which the activity can be started earlierly. Okay. What is the earliest time I can say? That is nothing but your EST. Usually, we are going to represent this as EST, earliest start time. This is the name itself says it is the time which is going to start at earlierly I can say, earliest start time. Then what about the earliest finish? Once we come across the definition of EST, of course, LFT will going to play a simple, right. So, earliest finish, yes, as soon as possible we are going to finish the task, that is your earliest finish time. This is the time required to finish the task in a easy manner, in a better manner, in a earlier manner I can say. That is why while giving the link earliest finish time you can say EFT is always equals to EST, that is earliest start time plus duration. Duration already we have discussed T. Yes, to reach from 1 to 2 which is nothing but activity A which consumes 2 days. This 2 is nothing but your duration. Yes or no? So, here at this initial stage for example 0, because once it requires 2 days to finish the task, of course 0, this 0 is the starting point of my project. This is nothing but 0 is nothing but your earliest start time. Here EST is said to be 0, no doubt, because we have started at the earlier, because this is event 1. Yes or no? Earliest start 0. This is your duration. Here we can come across earliest finish, At what extent we are going to finish this task? 0, this 0 plus duration 2. Of course, after 2 days, no doubt task A is going to complete it, because earliest finish, we have finished. Yes sir, this is earliest start plus duration, earliest finish, and we can give even link in something like this. Earliest start time is also equals to earliest finish time minus duration. We will get earliest time, because they are interlinked with each other. Earliest finish, earliest start. Okay, so LST is LFT minus D, whereas EFT is earliest start plus duration, whereas earliest start is finish minus duration. Okay, they are interlinked with each other. One is at starting point and another one is at finishing point, I can say. Okay, then once we come across earliest time zones, the next point we are going to discuss something is called latest start time and latest finish time. That we are going to represent by LST and LFT. Latest start. See, the name itself says latest start time. Okay, so the definition goes something like this. So latest start time is the time that an activity can be finished without delaying the completion of the project. Okay, so earliest start, we need to start the project at the specified time without delaying. Please, we should keep this point, without delaying the project time. For example, total project time is around 10 days. So we need to select the earliest, the latest start of that project without delaying that total project time. For example, I will take one live project example to correlate how they are going to differentiate with each other. Okay, because the concept called latest start time itself says something about the latest start time is always equals to latest finish time minus duration, whereas latest finish time is equals to latest start time plus duration. By observation, see here, EFT is EST plus D, whereas LFT is LST plus D. They are looking like same, but actually they are looking like same, but in practice, while constructing a network diagram, they are not going to become same, because earliest start and earliest finish are always as early as possible. We need to start the project, that is earliest start, as well as earlier as possible we need to finish the task, that is early finish, whereas latest means we can take some elongations in the duration of the project, or we can take some time duration even more than that of earliest, I can say. But latest, by latest, for example, usually we are going to call a statement called, yes, as early as possible we need to finish this task. Okay, so next today or tomorrow is the last day to finish the project, that is the flow. Latest by tomorrow we have to finish the task means what? We should not supposed to prolong. Yes, we should not supposed to prolong that particular task after that day. So that itself is the latest one. More than that we should not permit. Yes, sir. See, because by observation EFT is EST plus D, whereas LFT is LST plus D. Then it indicates EST and LST remain same? Definitely no. Because earliest start is the time which is going to start set earlier, whereas latest is the time which is going to finish that particular task without delaying the total project times. Yes, so durations will remain the same, because consumption of an activity A of this D1 will remain same for both EFT as well as LFT concepts, but this LST and EST concepts will not remain same. Yes or no? So by end of these two parameters we will come to know earliest as well as the latest difference. So in general I can say latest start time is the time that an activity can be finished without delaying the completion of the project, or total project time, I can say, total project time, I can say. Then similarly the latest finish time is the time in which an activity can be finished without delaying the total completion of a project. Okay. So of course they are interlinked with each other, LST as well as LFT, right. Then the next point says something about total float. The name itself says total float. We are going to represent it by TF, total float. Then what is total float? For example, see why we are going to differentiate the time zones into earliest and latest. Within that we have start, finish, task, start, finish, because we have some, for example, if we have only one task to reach from point A to point B is the only one task, then your concepts may remain the same. For example, your LST as well as EST may remain same, because they don't have any other interdependent or other parameters to link. Yes or no? Because they are purely depends on only one particular activity. After completion of that, second one will start. So, no doubt in that situations you may come across EST as well as LST may remain the same, because there is no any other alternative tasks are there or activities are there. But in practice we may not get always a single linear activities, I can say. We have come across network systems, there are so many other dependent activities are going to run simultaneously after completion of one over the other, I can say, but at last they are going to end up with the same, no doubt. Yes or no? But once you are going to come across more than one activities or more than one dependent activities, yes, then the concept of EST and LST will going to vary, because the durations of those two simultaneous activities may not remain same, may not remains consumed the same time, I can say, duration I can say, because activity A, for example, activity A and B will start simultaneously. Activity A required 3 days to finish, activity B required 6 days to finish. After third day, activity C will commence, but after 6th day, 7th, activity B, then D will commence. Then which is not supposed to link both or remain same. Yes or no? Earliest, at the time of calculating earliest, we need to go through the earliest time the project can start as well as finish, whereas latest we need to come by reverse. So, the one which consumes more time, on that parameter we need to come in a reverse order, so that we can get the latest start and latest finish. Okay? Then coming to total floats. Total floats are nothing but, so while representing that, TF is a total float, it is always equals to LFT minus EFT. That indicates what? Total float is defined as, it is the difference between latest finish time and earliest finish time. Yes, latest finished. By latest we are going to submit it on 23rd of this month, something like that. That is latest finish. Then what about the possibility of earliest finish of that particular task? It may be even less than that, or it may be equal at some extent, I can say. Yes or no? So, that a difference we can call it as total float. Yes, by hook or crook I will complete this by 20 days probably, but the maximum days they have allotted it as around 23 days. Let us say an example. That difference of 23 minus 20 is nothing but your total float. Yes, and this link can also be represent something like this, that is total float is the difference between latest start time minus earliest start time. Latest start minus earliest start, the difference between these two will give you the total float. Yes, while going to solve some problems related to network diagram, we will come to know how they are going to vary with each other. Okay. Then the last one is the free float. The name itself says free float. Yes, so free float is defined as or represented by FF, and free float is defined as the difference between earliest start time of following activity minus earliest finish time of this activity. Yes, for example, if you have one particular activity or task within the program or within the system, I can say. Okay, so activity A will commence at first, then B will start next, C will start next, so on, D, E, F, so on. There are some activities are there, and at the same time, in some cases, we may come across some activities of simultaneous activities, I can say. That means what? A and B can be starts concurrently. Then B, C. Of course, A and B are two activities, then C, D are dependents on A and B, let us say. Then once again, E and F will be the continuation of C, D, in continuations, I can say, linear activities, I can say. Like this, if we have some more than one linear activity diagram, in that cases, this free float concept will going to play a major role. Always our intention is to make the free float should be 0. Then only we can say whether the path is critical one or not. Of course, while constructing a networks, we have to follow two things. One is, two techniques, two methods, I can say. One is critical path method and program evaluation and review techniques method, I can say. That is per CPM and PERTs. Okay. So, free float is defined as the difference, or it is the difference between earliest start time of the following activity minus earliest finish time of this activity. Okay. So, difference between those two is nothing but your free float, right. So, on these two concepts we are going to decide whether the path is critical one, or which will consume minimum durations to finish the task, or which will consume the maximum durations to finish the task, right. So, these are the basic elements to be considered without constructing a network diagram. Okay. So, in continuation with that, the next point is the procedure to draw network. That is very, very important. How to draw a network systems. Right now we have to come across the important terminologies used in network systems. Okay. Of course, once we took some example, for example, let us say one task, I will take some building is an example. So, land acquisition, then registration process of land is activity A, which requires 10 days duration to finish the task. So, soon after completion of that land purchase and everything, we are going to start with jungle clearance, that is we need to clear the entire site, okay. That is activity B, which consumes 1 week, let us say an example. Okay. Similarly, activity C, earthwork excavation in foundation, which consumes 10 days to finish. Activity D, E, F, so on, okay. That in turn induce anti-termite proofing or strengthening of earthwork, I can say, okay. Excavated portions, I can say, I need to make it strengthen, so that I need to construct footings over that, okay. Then erection of footings, erection of columns. These are all the different activities that involved within the building, I can say. So, how to observe these activities and their interdependencies, and by observing these things we need to concentrate these basic terminologies and we need to construct a network. So, that if you observe that network diagram, right, even a non-technical person can also identify what is exactly the process takes place, or how the process is going on, or at what place we are at that particular point. Everything can be observed in a easy manner without, because explaining everything to everyone is not a single task or simple task, I can say, because someone can identify the technical terminologies, someone may not, I can say. But once we come across these types of diagrams or network systems, so that we can easily observe then what all the flow diagrams are takes place within the process. So, before going to start with constructing a diagram, first we need to observe the procedures to be followed to construct a diagram. So, we need to identify the activities within that, yes, and we need to observe what are all the duration of that those particular activities are there, yes, and we need to observe the interdependency of those activities, whether the activities are done simultaneously, concurrently, or they are immediate predecessor, or they are only predecessors, or they are successor or immediate successors. Everything we need to observe, and we need to concentrate their durations. At the same time, we can observe their latest start, their latest finish, their earliest start, earliest finish. We can identify and we can mark on that entire network systems, yes or no. Then I can easily calculate the total float as well as free floats. By observing all these important parameters in that particular network systems, we can say whether the path is critical or which path is said to be critical, yes, and which one is the better one, I can say, and which one will consume more resources. Everything I can elaborate and I can categorize it into different network systems, I can say. Okay. So, in upcoming class we are going to discuss something about how to construct network diagrams by taking one practical problems, I can say. Okay. Thank you.